Hello, and welcome to the third and final video of Intro to Python using the Spyder IDE. In this video, we're going to run a scatter plot, run a correlation, run a simple ordinary least squares regression, and run a multiple OLS linear regression. So what we're going to do first is we're going to go ahead and run a scatter plot. So first thing we do is from the matplotlib module, we're going to run scatter. And we say corruption2, that's our y variable, and we have our x variable. So it's going to go x and then y. So corruption is our x, GDPPC is our y. Going to go ahead and run that. We're going to add in a label for our x label, which is perceived corruption. We're going to add a y label for perceived corruption, or not, a y label for gross domestic product per capita. And we're going to use matplotlib or plt.show to then show the figure. If we click over here, we can then go ahead and see. So I'm going to go ahead and just highlight all this together, run it all at once. If you do it line by line, it's going to be that blank image, but here's what we want to see. So I'm going to go ahead and I'm going to save this. And oops, that's not what I want to do. No, I do not want to get started. So I'm going to go ahead and open up this new one. And there's our scatter plot. So we can see that there's a negative trend here. So it looks like there's a negative relationship. We do have a couple of outliers here, but in general, as we increase perceived corruption, or as perceived corruption gets higher, more corruption, GDPPC, there's a reduction. We're not making any causal claims, just saying that there's a relationship between these two variables. Great. So what we can do now is we're going to compute a correlation coefficient. And then, so this is going to be for determining the relationship between GDPPC and corruption, leaving corruption on its original 0 to 10 scale. We did the most basic graph. Now, for correlation, close to 0 indicates that there's no relationship. Correlation close to 1 is, or -1, is going to be very close to a perfect straight line. So either positive it's going to be a reduction, negative is going to be a reduction, positive is going to be an increase. So it depends on the directionality of this. The closer one, the closer to a perfectly straight line. The regression then also can tell us about the line in question, the rise over run or the slope. So a line is defined as the slope and intercept, and that will tell us whether those two coefficients, the intercept and the slope, are statistically significantly different than 0. So what we did was we went ahead and did this scatter plot, and now let's go ahead and look at that measure of association of the variables. So a sign indicates an inverse relationship, directly proportional relationships versus those two. So a 0 would be no relationship, a valuable one would be a perfect positive relationship, and a negative one would be a perfect inverse relationship or negative relationship. So when you go ahead and say df comp corruption2, we're going to correlate that with GDPPC. There's a negative 0.89, so that's an inverse relationship. As perceived corruption gets higher or larger, GDPPC is reduced. So great, we can see that we have a single correlation coefficient there. We can then follow this up by using a regression. That's looking at the specific relationship of those two variables and allows us to get one variable given, we can actually guess what that variable is for GDPPC if we know the perceived corruption scores. We're going to regress GDPPC, which is our dependent variable, over corrupt2. So we have saving the results of an OLS, ordinary least squares regression, GDPPC regressed on corruption2. We have our y, corruption2 is our x, our data frame we're using, our object is dfcomp, and we're going to fit this. So we're going to store that fit as an object. We're then going to go ahead and print this and get the summary. So we have a lot of information here. We have our model, R squared. We have our F statistic, likelihood ratio, residuals. We have our coefficients. Let me go ahead and move this over a little bit. Our intercepts, our corruption2, our omnibus regression, and some notes here. So then from this, we can then extract what is our intercept, and both of these are statistically significant. Let me go ahead and just gonna move this over a little bit so it'd be easier to see. There we go. So now it's a little bit easier. So we can see kurtosis, omnibus. We have our OLS regression, because I'm using a smaller screen, kind of scrunched it a bit. Or F statistics. So overall, do we have anything? Yes, statistically significant. We're able to explain almost 80% of the variance of GDPPC using corruption too. We have both statistically significant intercept and slope. So not knowing anything about a country's corruption too, our best guess is going to be the physical coefficient. We just need that scientific notation, move that over full decimal points. Okay. Is statistically significant, and we have our upper and lower bounds. So for each unit increase in corruption 2, we're seeing a reduction of 4,761 in GDPPC. We can then extract these to then create a visual. So what we're going to do is we're going to get the slope, intercept, R value, P value, standard error, and we're saving those, and we want, so we're going to run line regress. We're extracting these coefficients to then be able to get a line of best fit. We're going to go ahead and create a line of best fit, predicting. So when you use this line to predict our best guess of what a country's GPPC is based on corruption too, and we can use this to kind of plug things in. So when we use line of best fit, we're going to use corruption 2 to predict based on that line what each country's GPPC is. We're going to then go ahead and create a scatter plot, and we'll take a line of best fit and put that in there. So we do that. We go to plots, and there's our line of best fit, that red line. We can then also do a multiple linear regression by just simply adding a plus and then another variable. So we're regressing GDPPC on corruption 2 and literacy. So we can run that. And if we print out the model summary, and let me just move this over a little bit more so we can see the output a little bit better. We can see what the intercept was. We have our corruption 2 and our literacy. So holding literacy constant, for each unit increase in corruption 2, there was a reduction of 3,510 of GDPPC. For literacy, for each unit increase in literacy, holding corruption 2 constant or controlling for corruption 2, there was a 95.7 roughly increase in GDPPC for each country, or for the country. Great. So this is Spyder. So it's a pretty good IDE. We can also do things like get the help stuff. So if we type in help, now put numpy. Nope, numpy not defined. Oh, I have to do, because I saved it as MP. If I run that, you can get the help information. Better option though, rather than trying to do that, is open up a browser and type in Python, numpy, and we can just look at the documents. And honestly, the documents are fantastic. They walk through all of the getting started, the user's guide. So look at the documents. There's a great online community, so you can find materials quite easily and solutions to your Python problems. There's also the Python docs, which is docs.python.org. And here's all the stuff in here as well. So, no, actually, pre-release, so stable. Okay, we can go through the different documentation, get a tutorial, and go through that as well. So I hope this video was helpful and enjoy using Python.